Welcome everyone. I am very happy to be with you today at Devnexus to talk about two technologies that I love, Spring and Serverless. I'm Julien Dubois. People usually know me because of the JHipster open source project, which I have created some time ago. Well, you can check out our website at jhipster.tech. I'm also a Java champion, mostly because of my work on Spring and JHipster. I'm a book author on Spring. And today I'm working at Microsoft in the Azure team. I'm leading the Java developer advocacy team at Microsoft. As part of this work, I do a lot of serverless. And so today it's a mix of my open source work on Spring and my work at Azure on serverless. And so we're going to talk about those two technologies and see how they work together. And while we'll do a lot of demos, I hope we will have fun together. If you have feedback, questions, or if you want to ask me more details, please contact me on Twitter at Julien Dubois. I'm usually very active there and I will be very happy to answer you there. So what are we going to talk about? We're going to talk about serverless. We will talk about money because, well, money is important. We'll talk about Spring. We will talk about Java and GraalVM because when we talk about serverless, usually we talk about something called cold starts, and for this, GraalVM is going to be fun. So why do we care about serverless? We want to use serverless because it's very simple to use. It has got a very low cost. It provides high scalability, and you should have zero maintenance. That's usually why people want to use it. Then that's all the hype. That's the marketing part of serverless. And here we're going to do demos and we're going to have a closer look at what this is about. And it's going to be a little bit more complex. So we're also going to talk about Spring. And why do we want to talk about Spring? It's because we don't want to be tied to a cloud provider. So I'm working in the Azure team. I'm going to use Azure Functions, which is a serverless offering from Azure. I'm going to use it for my demo and for a general discussion, but here we're going to use Spring on top of it. And like in the good old days, you were using JBoss or WebLogic, and you were using Spring on top of it to abstract from the API from your application server provider. Well, with Spring Cloud Function, it's the same thing. You've got an abstraction on top of your cloud provider, so you can develop your application using the Spring ecosystem, using the Spring API, and then you've got a very little API which are specific to your cloud provider, so that allows you to be more portable. And as a developer, that's something I like. Of course, you still need to know how your cloud provider works in order to optimize your cost and your performance, but that's another story. So let's talk about money. As a general rule, in a classical situation, when you buy a VM, well, you pay for your VM per day or per month. When you use serverless, it's not the same thing. You pay per request. So when one of your end users does a request, you're going to pay some money for it. Very little money usually, but you will be billed by the number of requests that goes to your application. That's the general rule. In fact, it's usually a multiplication between the memory you use and the CPU that you use. So the time that you consume inside the machine and the memory that you use. That's the general rule. Then it's more complex than that. Well, first of all, most cloud providers have got a big free tier. That's the case with Azure. So you will not pay for, I would say, basic usage of your application because we've got a very big free tier. Then it's also more complex because typically with Azure, we support multi-threading. So if you go to other cloud providers, it's usually not the case. So on Azure, if you have two requests arriving at the same moment, you will only be billed for one request. So that's costing you less money. You also usually pay per bucket of CPU or RAM. So typically in Azure, you pay for 128 megabytes of RAM. So if you use less RAM than that, there's no need to optimize. You are already having the lowest bill possible. So that's important when you think about money. You need to optimize some stuff, but not everything. You need to be careful about where you spend time optimizing, depending on the way you are billed by your cloud provider. And last but not least, usually you don't only pay for your serverless function, you also pay for traffic, storage, monitoring. So when we talk about money, you need to take all of this into account and in order to optimize your cost. Last but not least, usually people use serverless to have something that is called consumption. So what's happening is that your application is starting up when there is a request. It stays out for some time, like for 20 minutes. That's basically the case with Azure. And if nobody uses it for 20 minutes, then your application will be shut down. What does that imply? It implies that, well, that's why you are paying so little money. It's because the application is not running all the time. It means also that when a lot of people are arriving, your application is out, so they have a good experience. But there's only one issue, is that first request, the first person coming to your application is going to experience what we call the cold start. So the application will need to start up for that person. And here we need to optimize if we want that person to have a good experience. So it's not always the case. There are two situations where this does not happen. Here I'm talking about a usual web application, but typically for Azure, serverless works for many other things than HTTP. So it can be when somebody puts some data in a blob storage, for example, then you can have a serverless function that is being run. So in that case, well, you still have a cold start, but it's not really important because it's not an end user waiting to have the request. And second thing, if you don't want this cold start at all, well, you can pay to have a better offering where your function will be out all the time. Of course, it will cost you more money, but it's a choice if you have a lot of users. So we'll talk more about cold starts very shortly because we're going to do demos. And usually, well, people are using serverless functions in two ways, either using something specific for the language. So here I'm focusing on Java. We have the same offerings for .NET or JavaScript. So we have a specific offering for Java, and you can deploy your Java application to a function. And that's the easiest path, what most people will be using, and that works very well. We'll do a demo just afterwards. Then this mechanism has a little bit of an issue, especially in Java. We just talked before about cold starts. Well, Java is a little bit slow to start. So when you do that, well, the first person who will do an HTTP request on your application will experience that cold start, and he will probably wait for a few seconds. So that's not a huge issue, but it can be a little bit annoying. And that's why people are trying to optimize that. And that's my second point. We're going to talk about GraalVM, which is a new technology that allows you to build your Java application as a native image. And usually most cloud providers also offer that kind of, I would say, generic mechanism to run your functions. So that's the case in Azure. It's quite recent. I mean, it's in general availability since a very little time. And so it supports any kind of native image. And if you build your Java application as a native image, well, you can run it that way. And well, you can test running your Spring Boot application compiled as a native image with GraalVM on Azure. That's what we're going to do. And well, let's have a look at this, how it works, and discuss what we can benefit from it. So let me close this and let's go to this sample application. So if you go here to Azure samples /hello Spring Function Azure, so that's the official Azure sample application for a Spring Boot on Azure Functions. I'm the one who did it, and I'm the one who is maintaining it. So if you have any question, well, just ask. You can clone that application. Of course, it's on GitHub. I've already cloned it, of course. Let me just open up my IDE. So here it is. What is interesting with this about Spring first? Let me open up those two files. The first one is hello function. As you can see, it is annotated with a Spring Boot application annotation. So this is a real Spring Boot application. It benefits from all the Spring Boot ecosystem. I can add, I don't know, if I want to use Spring Data GPA, I can use it. If I want to use any kind of Spring Boot starter, it's going to work here. So that's a very good, first very good point about using Spring Cloud Function is that I have access to the whole Spring ecosystem. So as a developer, I will be more efficient than coding my application manually. Second thing, as you can see here, I'm coding my function as a Spring Bean. I don't depend on a specific Azure API. Well, that's why the second file is here. So we are working currently, the Azure team, myself, and the Spring Boot team are working together in order to reduce that file. We would like to suppress it, basically. But today, you need to use it. And this file, as you can see, the annotation, it's a Microsoft annotation. That annotation is the link between Azure Function and Spring Cloud. So what you need to do today is to create those two files. There is one which is specific to Azure and which basically maps your application to Spring. And then you are in the Spring world. And as you can see here, my function is very easy. It's just telling you welcome, giving you your name. It's a very simple application, but it's a proof of concept. As a developer, what is interesting here again is that you don't depend that much on your cloud provider. You are coding with Spring, so you have the abstraction and you have the ecosystem of Spring, and that's really cool as a developer. If you want to run that application, there are two ways to run it. You can run it locally or you can run it in the cloud. So here I'm going to use some specific Azure tooling, but whatever your cloud provider is, you probably have something similar, or otherwise you need to change your cloud provider. Let me just show you how it works by running it. So here I've got a specific Maven plugin for Azure. I can just click on Azure Functions Run. And this is going to run an embedded version of Azure Functions inside my IDE. And I will be able to use my function locally. So here it is. I can say hello here, and it's going to answer me. So let me open up my console. I'm going to say curl, and my name is going to be sent as a post parameter. So let me do it that way. And it's answering me, welcome, Julien. So I'm happy. I can test my application here. I can debug it here. It's all good. And if I want to deploy it, so I've got here a Maven plugin to deploy my app. Well, let's do it just to see how it works. So it's going to build my project, package it, and send it to Azure. If you don't know anything about Azure, well, you don't need to. For one very good reason, it's because this Maven plugin is pretty smart. So it's going to create the Azure resources that it needs to be running. So inside Azure, it's going to do three things. Let me just go to my Azure portal. It's going to create what we call a storage account. So it's something that stores some data, and that's why your Azure function is going to be stored. It's going to create what we call a service plan. So a service plan is basically how you're going to be built. Inside that plan, it will create a function, and that function is what is going to be run. And last thing, it's adding application insights, which is our monitoring solution to monitor your application. So everything is created for you. You don't need to know about those in order to use them. Then it's better, of course, to learn about them if you want to use them efficiently, but it's pretty easy to get running. So it deployed my artifact. As the resources were already existing, we used them, but it's pretty easy. And it's available here on the web. So let me just do a curl again. Let me just use this one again, but I'm going to change the URL, of course. And this time I'm getting an answer from the cloud provider, so from Azure, and here it is, welcome, Julien. That first request was a bit slow. That's what a cold start is. It takes a few seconds, and that's exactly what I experienced. If I do it again, now my function is hot, and as you can see, it's faster. Let me add a time in front of it. So it's taking like, well, nothing. It's 131 milliseconds to come from my laptop to the cloud and get the answer. We'll try to experience some cold starts. The issue here is that you cannot plan them. Basically, Azure is going to shut down my app after some time. Unofficially, it's 20 minutes. So we can wait, we can try to force it, but it's a bit complicated to force it. Basically, my experience is that it takes a few seconds, like I would say 6 or 7 seconds to have your app running. Then that's that's your usual experience, and you can be lucky or unlucky. So sometimes it's faster. I add sometimes for 2 seconds, and sometimes it's slower. It took me sometimes 20 or 25 seconds. So that's basically the biggest issue that people have, and that's why they usually want to move to GraalVM, and we're going to discuss that shortly afterwards. So we saw our Java app. We saw that it was quite easy to test locally and to deploy. And of course, here I can code anything I want, and I'm very productive. So as a developer, I have I would say, usual experience as a developer. I can develop in my IDE, I can test locally, and I can deploy very easily with that Maven plugin. So it's pretty good experience. Usually startups like this, because it's very easy for them to have their code running, and then there's like nothing to do because, well, you are in production. Azure is, monitoring, updating, scaling everything, so there's nothing to do. Let me just show you a little bit more about my function here. As we can see, because I just want to give you a few hints about what you should do when you deploy functions on Azure. First of all, you need to use Linux. It's a bit surprising that Microsoft is better on Linux than Windows, but if you want a good experience, please use Linux. It's working a lot better than Windows here. We're using Java 11. By default, it's Java 8, but you can force it to use 11. It's supported, of course. And if you want to test it, we've got this little web interface where you can click and test your app. I prefer to do it on my laptop with my IDE or with my command line, but typically you see you can test, you can do post request. Well, I don't have anything here, so it's going to probably give me a little error message because I want to go fast. But as you can see, we've got everything to get you started. Yeah, I said welcome, so I didn't supply any name. Please provide a name. So that's part of my code. So that's cool. So here is my app running, and as we saw, it was pretty fast and easy. Not a big deal. Now let's try to improve that and move to GraalVM. And we're going to see that things are going to be a bit more complex, but that's part of the fun that we're going to have today. So if you want to use GraalVM, please go to this other GitHub repository. So it's GDubois. So this is mine. This time it's not an official one yet. And GDubois / Azure Native Spring Function. So this is an application that I forked from some official sample code from Pivotal from VMware. So that's from the Spring team, but I modified it quite easily for Azure, and because I've got some tricks I want to use, and I'm going to show you all of this. So if you have a look at that code, let me open it up in my IDE. I'm still doing here a Spring Boot application with add Spring Boot application. So it looks a lot to what we just did before. It's still Spring and it's ecosystem, but I'm going to have some limitations. First of all, you can see here that I'm telling you, I'm not going to use proxies because I'm using GraalVM. So I have some limitations. Here it's just an annotation, so not a lot of things changed, but you can already see that I'm going to have some limitations. That's also why a big part of the Spring Boot ecosystem is not available here, because not everything works with GraalVM. More and more parts of Spring are working with GraalVM, but not everything. So if you do an hello world like I'm doing here, this is going to work. But if you do something more complex, honestly, you will get some trouble. But for something simple like this, it's going to work. I'm doing Inorganic Function. So it's basically the same thing as before. It's when I apply my function to a string, it's going to say hello. Instead of saying hello, my name is saying hello from a native function, my name. So basically the same thing with a little twist here. And as you can see here, I'm also doing some specific configuration. So that is because of the way Azure Functions is working. So Azure Functions here does not know anything about my app. It doesn't know it's a Java application. It just knows that it's a native binary that is being run. And so I get less configuration and help from Azure Functions. So I need to do more tricks. So here typically I need to know the port of my application. So Spring is running by default with a specific port, and here we need a port that is pushed by Azure Functions. So I'm just taking the port as part of an environment variable, and I'm fixing it inside Spring. So as you can see here, I got a bit more tricks, and also I need to do a bit more configuration here. So those are in fact the same configuration that we had before when I was using Java, but we didn't see it because with Java we have a Maven plugin that can generate all this. So those are specific JSON configuration files for Azure Functions. They are generated automatically when you use Java, but with GraalVM, again, you have like nothing. You are just having a binary. So you need to build all this. So it's a bit more work, but basically, once you got it, it's not that complex. The real trick is in the build process. So when you build your application here, well, I'm going to compile it with GraalVM. So you can see here my shell script. It's a bit complex, and I've got some parameters specific for Spring. And once it's built, so that's basically what the Spring team gives us. Once it's built, I'm doing one more trick, so that's specific to me. I'm using a tool called UPX. So here it is. And UPX is used to zip, compress my application a lot better than what GraalVM would have done. So when you do this, you're going to have a binary which is much smaller. And as it's smaller, you win on several parts, but most importantly, your cold start will be much better. Now let's discuss exactly what happens when you have a cold start. So you have a new server which is spun up, which appears. It needs to download your binary. So it's going to download it, and it's going to unzip it because it's zipped, and then it's going to run it. And so here we are trying to solve two issues. Downloading it takes time. And for this, the smaller the binary, the better. That's why I'm compressing it here. And then running it takes time. And that's why with GraalVM, I'm trying to improve my startup time compared to what we have with the GVM. So I'm doing different tricks here to try to have the smallest and more efficient binary that I can get, and then have a better cold start. Just one last trick here. As Azure Functions is waiting to have a zip file, and here we are compressing it with UPX, I am like recompressing it, but with 0. So I have a zip file which has just a binary in it, which is already compressed. The way it works here is that, my idea here is that Azure Functions will download that zip file. It will unzip it very fast because there's no compression. Then it will get the binary, and that binary, which is compressed, is self-sufficient. So it will uncompress itself and run itself. If you want to see this in action, I've got here a little GitHub Actions script that you can have a look at, where everything is described. So what we are doing here is we are checking out the code. We are installing GraalVM while we cache a Maven. We then basically build a native image with the script that we have just seen. Once it is generated, we log in to Azure and we deploy to Azure Function our zip file that we just created. As it's inside GitHub Actions, I just need to git push my code to have this running. Why do I do this? Well, first issue we can imagine here is that it's building a native image, and I'm on macOS, but Azure Functions is running on Linux. So my native image is just not going to work. So I don't have an image which is portable. So I can build it locally, but honestly, it's pretty annoying. And once it's built, I cannot deploy it because it's another system. So here I'm offloading all this to GitHub Actions. So GitHub Actions will be able to build a native image on Linux because it runs on Linux, and send it to Azure Functions. So that's basically the only way to do it efficiently and without too much trouble. So the goal here is to do just git push and be in production. But as a developer, it's pretty complicated for me to do a local build, a native image build, and test it. I can test this as a Java application, but as a native image, it's pretty complex. So that's the first issue that we have. Second issue that we have is that it's pretty slow to build. So let's go here to my GitHub Actions and have a look. So I did some build. As you can see, sometimes my builds are failing. I'm not perfect. And usually my build takes something like 7 minutes. So it's much longer than what we used to have with Java. But as long as it's running inside GitHub Actions, honestly, it's not that bad. You just need to wait a little bit. And you can see it building my native image, for example. That's what takes the most time, 6 minutes. Also, compressing takes a little time with UPX, as you can see it here. If we have a look, you see the final image is only 16 megabytes, so it's very small. So yeah, a lot of people talk about Spring being huge. Here I can make a native image of Spring, which is only 16 megabytes, which is like incredible. And my startup time inside GitHub Actions, which is not a very powerful system, my startup time is only 100 milliseconds. So that's very fast. So basically here I have an extremely small image that takes no time to start up. And we can hope that when we do a cold start, it's going to be extremely good. Let me just show you inside Azure how it looks like, just to really prove that the image size is this big. I'm going to have a look at the storage. So let me just go to my Azure Storage Explorer, and my native image is here, blob container, and it should be stored here. GitHub Actions deploy. Here it is. So it's 16 megabytes. We can see it here. So indeed, it's extremely small. I can download it and run it. Well, if I have Linux, I could run it locally. That's a nice way to test what has been deployed here. Now let's have a look at how it works in production. So let me go to the Azure portal, and this time I'm in my Spring Functions native resource group. My function is here. Here again, it's a Linux function, but without Java, without anything. This time, Azure will understand a lot less about it, just understanding that there's a native image that understands HTTP, and we can test it like we did before with Java. Let me do it on the command line again, and this time with, let me get the function URL, and this time I will keep the curl, the time command, so we see how much time this is taking. And well, it was immediate, so this time it was extremely fast. Honestly, it depends on your usage. Here we've got a very good feedback. Honestly, it's not always that good. I usually have something around 4 or 5 seconds, but it really depends. Here I've been lucky. Now, of course, it's hot, so if I do it again, it's going to be extremely fast. So usually this gives a better experience than what we have with Java, but really it varies, and it's still a little bit hacky, as we have seen. So this way of deploying your function is probably a good solution for the future, because again, you've got better startup time, better memory usage, cold start is extremely good, storage is very, very good. So everything is better than what we used to have in Java. Then, as we saw, as a developer, I had more trouble to test it, to build it, and also my ecosystem was limited. I could not use the whole Spring ecosystem. Now there are some frameworks which are competitor to Spring, like Quarkus and Micronaut, which provide also an ecosystem with maybe a better support for other APIs. Spring is arriving there very strongly. So in the end, I believe that in Java, we will have 3 competitors here. We'll have Spring, Quarkus, and Micronaut, which will all provide that kind of capabilities of building your function either in Java or as a native image. Also, as we saw with Azure Functions, I had to do my own build scripts, and that's a bit complex and a bit risky, because I mean, it's as you saw, I had some failures in my build pipelines because it's complex to do. Hopefully, in the future, we'll have also better support here, and at some point in the future, you will probably be able to deploy with confidence your application as a native image and benefit from it. and it will be the same thing as deploying a Java image. It's just a matter of having a different build. So you would be able to develop and build locally on Java, and then git push to the cloud, and probably have a switch, and it will either run as a Java application or as a native application with the benefits from having a native application. So I hope we had fun together with serverless Java and Spring. Again, if you want to test this, so for the Hello World with Java, this is very simple. Just go to the official sample app that I did. It's extremely easy to do and test. Again, we've got a very big free tier in Azure, so basically it's free and easy to use. So just do it. Then, if you want to do something a little bit more advanced and fun, you can have a look at my Azure native Spring Function project. There are tricks that you will not find anywhere else, especially compressing everything with UPX. Oh, I forgot to give you the URL for UPX. It's .com. It's UPX/UPX. This works very well. It's surprisingly good. So I highly recommend it, but of course, it adds more complexity and risk to your project. So don't use that in production, honestly. Use this to have fun, like we did. Use this to have a glimpse at the future, but don't use it for production code right now, honestly. Thanks a lot. If you want to give me some feedback, I would be really happy to have it. So please contact me on Twitter at Julien Dubois, and I will be very happy to talk with you. Thank you and goodbye.